Hello everyone. In this video, we are going to familiar with data structures. Content of this video is definition of data structure, why data structure is used, and different type of data structure. Right. So before starting our discussion on data structure, let me take some images and please keep observe those images and get some inferences from that. Right. The first image is these are the collection of books which are scattered form. And second image is these are the collection of clothes which are in scattered form also. Right. Now compare this image to next image. Now in this first image the books are in scattered form, and in second image books are in organized form. Right. Next one. In the first image, the fruits are there. In second image, fruits are organized. Now, in this image, the clothes are scattered form, but in this image, clothes are organized form. So, the question is, why I am going to show this image? What is the relation of this image with data structure subject? No, what is the advantage of organizing these things? Right. The first advantage is looking good. These books are looking good, and this is scattered form. Second advantage is we can access efficiently. We can access these things from this organized way. We can access these things efficiently. But in this organization, we are not able to access efficiently. It will take more times. Right. Similarly, in case of data structure, here things are organized. But in data structure, in computer, data will be organized. The whole thing about the organization of data. So informally, we can say data structure is just like a container of a data. Right. So container of a data means just data which are kept in some container. Right. And the formally definition of data structure is a particular way of storing and organizing data in computer memory during the execution of program so that it can be used efficiently by an application software. In this formal definition, I would like to point three things. The first thing is uh, where data is going to organize. This is first point. Where data is going to organize, and when data is going to organize, and by whom data will be accessed. Right. So we have seen the real life example of clothes, books and fruits, but now let's take an example of computer system. How in computer system data structure is going to use. Now for example, suppose there is a main memory. This is main memory. Right. And this is suppose an application software which is for the printer. Suppose you type control P, then what will happen? An application will be open that is for the printer, right? And you have to supply the page and also commands to print the pages, right? So these pages are the data, these commands are the data, and this application is going to access those data in particular discipline or fashion. So for your information, in computer, printer follow first in first out. It means if you are giving the first page command, then that page will be print out, right? So these are the data, and this is the application software. So this application software is going to use the data in efficient manner, right? Okay, and when? During the execution of the program. What about execution means this application and data both are in main memory, and when program comes under the main memory, that is execution phase. Suppose this is the data structure. Suppose I am talking about the data. If the data kept in hard disks, hard disks or secondary storage or auxiliary memory. If you're keeping the data in hard disks, then this data is termed as database, right? And a particular software will manage this type of database is known as DBMS, database management system. Okay, and suppose I am talking about the data. If data is organized in array of hard disks, then such type of data is termed as data warehouse. Data warehouse. This is the collection of traditional data used for the analysis point of view. And if the data is kept on cloud, then that data will terms as big data. And another point is data science. You also heard about this data science. If you apply the science on the data, that will refer to the data science. So why I'm going to say this? Ki data is here. Data is data science. Data is big data is also here. Data warehouse data is also here. In database data is also here. In data structure data is also here. So what is difference? Difference is where data is going to organize. Where data is going to organize and when data is going to access and who is going to access the data. Right, the matter is this one. So simply, so we can say the data structure is a particular way of storing the data in computer main memory, right? Not secondary memory during the execution of the program, so that an application software can efficiently use. Right, now the question is why data structure is required. The first question is why data structure is required. You know, suppose you are going to create an application, you are going to design an application for simple application, arithmetic, like simple arithmetic calculator. So that's easy. You can create your simple application like arithmetic calculator using the primitive data types, using the integer, character, float. Easily you can create your simple application. For simple application like arithmetic operation, we can do with the user defined data type. Already user defined data type, integer, character, floats. But the serious application where need to store the lot of information like name, age, address, contact number, we need a concept of data structure, right? Simple. Now, and sometime it may be happen data structure like array and simple data structure will not solve your particular problem. Then in that case, you have to customize your database, right? With the help of primitive data structure, like integer, character, float, right? So we will discuss later what are the different type of data structures are there. So that's why data structure is comes into the picture, right? Now what are the different types of data structure? First one is primitive data structure and non-primitive data structure. Second one is linear and non-linear data structure. Third one is physical and logical data structure, static and dynamic data structure, and homogeneous and non-homogeneous data structure. So let's discuss one by one types of data structure. The first one is primitive data structure. On the basis of, you can categorize this primitive and non-primitive data structure on the basis of manipulation criteria. How the data is going to manipulate. Integer type data, float type data, character type data, boolean type data, you are going to manipulate on such type of data, right? And array is non-primitive data structure, linked list, stack, queue, tree, graph, all these things are non-primitive data structure. So you can say like simply, and primitive data structure is also known as system defined data structure. Why system defined data structure? Because in compiler such type of data type is already defined, and compiler is system software. And system defined data structure means system defined data structure means a data structure that is defined by the system. And compiler is a system software, and in compiler already this type of data structure is defined. That's why we can say primitive data structure is also known as system defined data structure and sometimes fundamental data structure also, right? And and right, and next one is primitive data structure and also known as user defined data structure and derived data structure, because we are going to derive the data structure on the basis of these primitive data structure, and these are the fundamental and these are the deriveds, right? When the data type and data structure is going to derive with the help of fundamental, that is derived data structures, right? So array is the collection of integer, array may be collection of floats, array may be collection of characters, like similarly linked list, stack, queue, tree, graph or the non primitive data structure, right? Next one is linear and non-linear data structure. uh, According to the storage criteria, it is occurrence, how the data is going to occur, how the data is going to store, right? And the basis of occurrence, we can categorize the data structure in two types, linear and non-linear data structure, right? In linear data structure, uh, one-to-one mapping is there, right? Elements are arranged in linear discipline. One-to-one mapping can be handled through the data structure, like array. In case of array, for example, now simple. This is the array. In case of array and linked list also. This is the linked list data structure. We will discuss in detail each data structure. So this element is one-to-one map to another elements. One-to-one mapping. These elements. This element is mapped with this element. This node, you can say. This node is one-to-one mapped with this node. That's why we can say linearly data arrangement. The data is arranged in linear fashion, right? Similarly, in case of non-linear data structure, the remaining are one-to-one mapping is done, and remaining are one-to-many, many-to-one, and many-to-many. These are the relationship can be handled through the non-linear data structure, right? For example, a tree and graph. Tree and graph is considered as non-linear data structure, and linear data structure is array, linked list, stack, queue, etc. Right? To stack, you can organize a linear data structure like this is a stack, right? This is also, you can say stack is this one. This is all one side open. Array one side open is stack. This is also a stack, right? This is also a stack, right? So one-to-one mapping is there. Queue. In queue also one-to-one mapping is there. In tree, this tree you can draw like this. In tree you can see here one-to-many relationship. This data is going to relate with this one and this one also. The one-to-many relation. And many to many, this data is going to relate it with this one also, this one also, this one also. Many to one relations, right? Many to. In graph, suppose I am going to take this one. This is the graph, and here the many to many relationship. This data is going to relate with this one, and this one also, right? You can see this, and each element has a number of predecessor and successor as well. The predecessor means this data had the successor of like this one. This is the successor of this node, and this node is predecessor of this node. This is the predecessor. This is the predecessor, and this is the successor of this node. Right. So we will discuss in terms of tree. Right. Next data structure is physical data structure. That's very interesting and important also. The physical data structure you can define array and linked list are combination of both referred as a physical data structure, because it describes how the spaces are allocated in computer memory. in case of array and linked list are physical data structure, and remaining stack, queue, tree, graph are the logical data structure. You know, physical and logical terms. Okay. With the help of physical data structure, we can implement the logical data structure. Right. So logical data structure is what? In case of logical data structure, you will find the stack, queue, tree, graph as a logical data structure, and we can implement the logical data structure using the physical data structure. You know, for example, suppose stack is there. In stack, suppose I am going to take this stack, this one. So this stack can be represented using the array and list linked list. Suppose I am going to take the queue. Queue will also implemented with the help of array and linked list. Tree is also implemented with the help of array and linked list, right? And graph will also implemented with the help of array and linked list, right? So every logical data structure is going to implemented using the physical data structure, because this is the fundamental, this is the basic data structure, you know, right? So you will study in your syllabus in this subject, implement stack using array, implement stack using linked list, implement queue using array and linked list. It means you are going to implement these logical data structure with the help of physical data structure. That's very important, so keep in your mind. Static and dynamic data structure. On the basis of nature of size, you can categorize the data structure in two types: static data structure and dynamic data structure, right? So in static data structure, memory allocation of object is allocated at the time of loading of the program. When the program is going to load, then static data structure come into the picture. Amount of memory required is determined by the compiler during the compilation, right? In the case of static data structure, suppose if I am taking the int arr 5, it means this array will create the 5 blocks of integer type. It means suppose I am assuming the size of integer is 2 bytes, then 2 5s are 10 byte will create it, right? And that will the fix for the whole program, right? But in case of dynamic data structure, the memory space required by the variable is calculated and allocated during the execution. You can change your size of allocated memory, right? And you can manage this dynamic memory with the help of library function like C. You know already malloc function. With the help of malloc function, realloc function, you can resize your memory location, and you can create your memory dynamically, and you can resize your memory dynamically, right? So you can just create your dynamic data structure with the help of set of library function in C programming language, right? We will discuss more on these data structure also. The next one is homogeneous and non-homogeneous data structure. According to holding data, we can categorize the data structure in two types: homogeneous and non-homogeneous. You know, very easy. This is very easy. Now, if the data structure containing the similar kind of data, so that data structure is known as homogeneous data structure, and right. And heterogeneous, if the data structure contains the two or more types of elements, that data structure will consider as a non-homogeneous data structure, right? So these are the different type of data structure and many more also, right? So, but this is the basic data structure you should keep in your mind. So we will discuss data structure, different types of data structure in further lectures. Okay, thank you for watching, and happy data structure. And this is a very important subject for a computer science student, right? And you know, most of the product based company like Amazon and Google and Microsoft are demanding this subject. Remember this point. And being a second year student of computer science and allied branches, I would suggest, request, or advise you, just think about the data, how data you can organize by own, because there are different type of data structure is already existing, like stack, queue, tree, graph. They are already well well defined how the data is going to store. But you can also think about the data. You can also think about how we can store the data in computer memory. Just discuss with your faculty, discuss with your teachers. Sir, I can store the data in computer memory in such way. In first phase, being a computer science second year students, I will suggest you. So in first phase, just think about the storing fashion of the data in computer memory. And in second phase, try to optimize, try to optimize the data structure in terms of time complexity. So thank you for watching, and happy data structuring and keep learning is the very important subject in computer science. Right? Okay, thank you for watching.